So, good afternoon. So, after lunch, we'll continue. So, before lunch, we have delivered on basic hydrogeology, then hydrogeology of NER, and artificial recharge structures, or how to do artificial recharge, why it is important, those things we have seen. So, in hydrogeology of NER, mostly you might have seen that some parts are under hard rock areas and some are soft rock. So, what Mr. Gogoi was presenting, that unconsolidated, semi-consolidated, consolidated, those things for easier purpose we are calling unconsolidated and semi-consolidated as soft rocks, and granite, basalt, whatever consolidated formation, fissure formation, we will call them hard rock formation. So, morning when I was telling that we have carried out this source sustainability for drinking water sources for JGM. So, this was a proud moment for us, that this SOP what we have prepared, this has been published by our Honorable President of India and our Minister Gajendra Singh Shekhawat in Vigyan Bhavan, New Delhi. So, JGM, its main aim is to improve ease of living of rural population and to provide functional household tap connection, FHTC they used to call, by 2024, and providing drinking water of prescribed quality. So, here two main things are there for JGM, that we have to provide sufficient quantity, that has been decided as 55 liter per person per day, per capita per day, and should be on a regular basis and for a long term. So, from here this situation comes of sustainability issues, that many sources are becoming dry. So, why it is becoming dry? As we have seen in Biplav Sab's presentation, the India map he has shown some areas are red. These are all those blocks are red because those are overexploited areas. So, in layman language, what is overexploitation? Overexploitation is you are having 100 rupees and you are spending more than 100 rupees. So, how you can spend more than 100 rupees? You can borrow, or maybe from your fixed deposit or bank you are using that water, that money. In our case, in water resource case, it is that water that is deposited in the aquifer for millions of years, thousands of years, that water we are using. So, groundwater recharge is a slow process. So, when naturally groundwater recharges in a system everywhere, so this system is a slow process. When this system got hindered or get altered due to our say urbanization, land use factories, so there are many factors which affect groundwater recharge. So when these issues come, then we have to do it manually, or say artificially we are doing. Even in some countries they used to call it as managed aquifer recharge, MAR. And in India, generally we use the term since long, it is called artificial recharge. So, in sustainability, what are the main challenges? These are the wide spatial and temporal variation of rainfall in the country, from 500 mm to say 250 mm in Jaisalmer, Rajasthan, to 1100 mm in Cherrapunji. That is a huge wide variation, and temporal variation, that in Biplav Sab's presentation you have seen, that during monsoon we are having our 70 to 80% of rainfall, other months it is very lesser. So, these are the variation. Then increasing population, every our population is going on increasing. So, there is always a pressure on our resources. In say 1950, when we got independence, that time our per capita water availability in India was more than 5,000 cubic meter for one person. Nowadays, it has come down to 1,100 cubic meter per capita. You won't believe, but it is true that this figure is lesser than Arab countries from per capita, if you say. So, India is a water stressed and water scarce country from in many regions. So, along with our increase in population, another issue is increase in food demand. So, because of our increase in food demand, we want food security for our people of our country. So, we need more irrigation, more areas to be covered. So, water extraction or withdrawal from aquifer is increasing, and impact of climate change. Now, every time you can see this year so many cloud bursts and other things are happening. So, whenever rainfall intensity is very high, that water will not get a chance to percolate or recharge the groundwater, rather it will just flow as surface water and it will go to river and ultimately it will go to sea. So, these are our challenges. So, first I will just tell you the base that where we have worked during the source sustainability studies in India. These are the 4 states and 4 districts we have studied. This one district is in Rajasthan, the top one. It is Sikar district, then Madhya Pradesh, then Karnataka, Chikballapur we have studied, and Tamil Nadu, Ramnathpuram. So, and that Madhya Pradesh one is Chhatarpur. So, we have studied in this 3 months time a total of 2,407 villages, and during this 2 months only our officers have completed study of all these villages. We have prepared block wise DPRs, and when we have prepared for all these districts are having unique and different challenges, but ultimately our government want that we should prepare a SOP so that every state can follow in a easy way. So, this is say one block in Rajasthan. So, when we have studied this is a Nimka Thana block, and total number of villages in this block were 79, and total number of sources surveyed were 582 block source this JGM sources we have studied. We found these are unconfined alluvial aquifer. So, alluvial aquifer are the best aquifer in the world. But what happens in this area, this alluvial aquifer, this thickness is in this area it is 60 meter, and so much water they have taken out that entire 60 meter is almost dry. Only in southern part, if you can see carefully, that southern part some dots are there, blue dots. There some 1-2 meter of water has left, otherwise that entire part has become dry. So, whatever rainfall is happening, it is unable to recharge that area. So, this is a Rajasthan issue. Then this is Madhya Pradesh Chhatarpur area. Here that main issue is it is a hard rock area, and not over exploited, but this area is semi critical, and one block is even safe in this area. So, here we have done the study for this number of blocks in A. So, reason for how we have categorized that some villages we are saying in this categories as good to good, there is no intervention required. That we have found only 8 villages are there where no intervention is required from human side, naturally that part will recharge. Then we are saying some part with, if we make some intervention that area will become safe and good, that number is almost 58. And even if we do something more intervention, if we do from government side, then also situation will not improve that much, moderate situation, that is huge number you can see in the third row. And poor with intervention, that is in those areas intervention is not possible at all. So, it is not that everywhere we can do intervention. So, these are the blocks we have prepared this type of maps, and with all details and DPRs we have handed over to Madhya Pradesh. Then say for Rajasthan, this part we have categorized further that good, moderate, poor. So, our task is that not only that technical people can understand, they are asking saying that that district administration people or DC, DM, they should understood our term easily. So, we have make these things as good, moderate, poor. Like this we have identified the area. So, this green patch is the good area, we are saying this area we can make recharge, it will become sustainable good, and this southern part, though it is we have seen it is in still some water is there, but that area intervention will not become very feasible because there are issues there. And in good area what we have seen, on what basis we are saying it is good, that yield is good, then depth to water level is okay, depth to bedrock is deeper, and saturated thickness is available. And this is Tamil Nadu Ramnathpuram. So, this is another very peculiar situation here. Here what happened, aquifer is available only below 270 meter, and top whatever water is present, that is saline water. So, and on northern part of this block only 3-4 parts are there where a little fresh water is available. So, what people, how people survive there? Generally what they do, they make some ponds. So, whenever rainfall come, that fresh water get accumulated there, they are using that fresh water, because if they make tube well also it has become saline. So, they cannot make water, use water of that area. And there are some parched aquifer. Parched aquifer are those aquifers which are very small in extension, not a big good extension. So, here can you see my cursor? So, this is a clay body, this is entirely as alluvium, but this part is clay and it is like this shape, na, saucer shape. So, because of that some fresh water get accumulated there. So, tube well constructed here, it can extract some fresh water, otherwise all are these are saline water. Actual water level in this area is below 1, because of parched aquifer in this area water level is higher, at higher level. And these are the ponds, you can see that these are getting dried, these are some pond people are making from where they are using water. Can you see this structure? Once iron structure is there. So, what is this? This is actually they are trying to recharge this area. They have make a shaft like thing with the, inside the shaft they have put boulder, pebbles, sand, everything, so that water can get inside it, percolate it and recharge this aquifer. So, this is a red area, salinity is more than 3000, you can see that red area. So, more than 3000 generally we can't use. In our northeast this value is generally within 500 or say generally 250. In hilly areas it is less than 250 in northeast. So, you can imagine how saline this part is. So, these are the during field photographs are taken when we have interacted with the people. And saline water, another issue is there in northeast, it is not there, it is called upconing. If you pump saline water, it will automatically it will come up to some level. So, some fresh water is there, it will get mixed up with it and it will destroy that fresh water aquifer. So, now this is Karnataka. Here what happened, all these blocks in this Chikballapur district, it is overexploited. This is a hard rock area near Bangalore, and you can see that 163%, 114%, 119%. That means that whatever groundwater, rainwater get inside the system getting recharged, we are using more than that part. Means 100% recharge, whatever amount is getting, they are using more than that, say 163%. And water level trend, you can see it is since 1998 to 2016. So in 1998, in that area water level was less than 15 meter, and in 2016 it has come down to about 45 meter. So water level is continuously declining, aquifer is becoming desaturated. So these are the issues that we have faced, and we have suggested them these areas which are these blue areas, these blocks are or villages are at very high risk. Then this green areas we are saying at risk, and yellow areas are safe, means we can do intervention and we can make them safe. So these are the studies that we have made. So when doing this risk assessment, we have instructed our officers to collect this type of data. Say first geotagging of source, then rainfall, what is the geology, depth to water level, pumping hour, then sustainability issues, what are the issues, and gap between demand and supply. So main groundwater related issues in these areas that we have identified, if we combine all these studies, this is declining water level, low groundwater potential, limited aquifer thickness, then low sustainability, inferior groundwater quality. Then we have prepared this SOP, standard operating procedure for sustainability of groundwater sources. So in this SOP, we have made 8 steps to be followed. First step is collection of basic information including geotagging. Second step is assessment of demand and supply. Third step is assessment of monsoon runoff. So Biplav Sahab has explained you before my lecture that uncommitted surface runoff, or have you understood that term? Means there is rainfall, so that rainfall whatever is falling, so the one part will go as to groundwater, one part will go to evaporation, some part will flow. So that flow also we can say some part is required for environmental flow, some part will be used for drinking water or irrigation supplies. So these are all those volumes, if we calculate, these are all committed, we have already done something. So after this, the water that remains, that is called uncommitted surface runoff. So we have to make assessment of monsoon surface runoff. Then fourth step is we have to do risk assessment of villages. Then fifth step is drinking water sustainability measures. So after risk assessment, what measures we can take? Apart from this, some steps we have provided, that is source protection, then groundwater monitoring, and technical and financial support. So we will go by one. So we have kept very basic minimum requirement to collect the information. That basic information we are saying that name of habitation, location, district or block, latitude, longitude, then population, kitna population hai, then aquifer type, soft rock, hard rock, we want to keep it very simple. Then type of structure, dug well, tube well, bore well, and sustainable throughout year, yes, no. गाँव वाला से पूछना है विलेजर से कि आपका पानी मिलता है नहीं मिलते है. Average pumping hours per day and water quality issue. We are considering only mainly these issues: saline, fluoride, iron, nitrate, and arsenic. These are the major issues in our India. Then demand and supply assessment, how we are doing, that is per capita, as per JJM we have to give per capita 55 liter per day, and number of days required, we know for drinking water 365 days we have to make supply. So annual demand will come by multiplying this number of population into per capita into number of days. Then this is my demand. Then supply assessment. So for supply, maybe there are in that village or neighborhood there are maybe one or two sources. So each source we have to take what is the discharge cubic meter per hour, number of running hours per day, then annual extraction. So we are multiplying this, and then we are taking that maybe some 15-20% say will go as waste or loss. So that is my supply I am taking, and from demand supply, if I make the minus one to another subtraction, then that is the gap assessment. Then assessment of monsoon runoff. There are many methods. We have kept it very simple, that say when you are doing for some monsoon runoff for some area, if it is agricultural area, then runoff coefficient we are taking as 0.020, that is say 20%, and area and rainfall you multiply, you will get the runoff, how much runoff is generating there. For habitation area, say like urban areas, say Guwahati, we can multiply it with 0.50, and for others we are taking it as 0.15. So very easily we can find out what is the runoff can be generated in this village. Now this risk assessment, this is the one major part. First we have to find out whether the village is at risk or not at risk. If we are at risk, then we have to make intervention, otherwise we did not make any intervention. So two parameters that we have decided for risk assessment are, say normal annual rainfall we will check, then tube well borewell discharge, then whether discharge is available throughout the year, then gap between demand and supply, geomorphology, because in hill situation will be different, in plain areas situation will be different, then depth to water level and quality. So say safe, we will categorize the villages in three categories: safe, at risk and high risk. So normal annual rainfall, if it is say more than 750 mm, then it is it comes under safe area. All the parameters should come under safe area, then it is safe. Say tube well borewell discharge should be more than 3 liter per second, then that is having a good discharge. Whether discharge or yield is available throughout the year, yes, no. If it is yes, then it is safe. Demand supply gap, no gap. Then geomorphology, plain or valley, we have to check, and depth to water level. If it is less than 10 meter, then it is safe. And iron, fluoride, arsenic and salinity, these are all values are given. If these values, that's water quality test has to be done. If the quality values falls under these values, then it is safe. So like this we have make for at risk and high risk areas. Say high risk, if it is hill or the village is situated in a high slope area, then it is always be at high risk. If demand supply gap is more than 50%, then it will be always at high risk. If this salinity or other things are more than permissible limit, then it is at high risk. So these are the situations that I have prepared. So say while deciding how to decide, there are so many parameters. Now how you will decide whether the village is at risk or at high risk or safe. So first situation is, say I am taking with very less rainfall, say less than 500 mm rainfall in that area. So parameters here what I am using is rainfall, terrain, aquifer potential, sustainability, aquifer health, risk assessment, and last one is groundwater quality. So terrain, if it is say slope is less than 10-20% or more than 20%, that part we have to see. If it is more than 20%, rainfall also is very less than 500 mm, it is directly it will go to high risk. If slope is less than 20% and discharge is say more than 3 LPS, so discharge is more than 3 LPS, we are making two categories, less than 3 LPS or more than 2 LPS. So, if discharge is less than 3 LPS, it will go to high risk. If it is more than 3 LPS, then we have to check whether water is available throughout the year. If yes, then we will go further, otherwise if no, we will call it as high risk village. So, now we will say aquifer health, so depth to water level. Depth to water level we will see, if it is less than 10 meter water level, then it is safe, that village. If 10 to 20, it is at risk, and more than 20 meter at high risk. And water quality, if any of your parameter falls under bad water quality area, then it will be considered as high risk village. So, like this for other rainfall zones we have made this, say rainfall is 500 to 750 mm. So, it is, this process is same with yes, no and more than 3 LPS. Here in less than 500 mm we have made discharge only two categories, more than 3 LPS or less than 3 LPS. In this case, second case, we are even taking more than 3, 1 to 3 and less than 3, 1. So, if it is less than 1, then it is high risk. If 1 to 3 or more than 3, then we will check whether water is available throughout year or not. If no, then high risk. If yes, we will check water depth to water level, and accordingly we will categorize the villages as safe, at risk, high risk. And JJM sources is always same for all the cases. If parameters are beyond permissible limit, then they will be considered as high risk villages. And this is the last situation. Here entire our northeast region falls under this category, that more than 750 mm rainfall, and you will be having this PPT, you can go through it. It is the same logic has been followed. So, after this making this assessment whether village or that source is at risk or at high risk or safe, then comes the question that you have to make some intervention. So, what intervention you can make? I have kept it only 2-3 structures, how to decide on the these structures that you have to make. So, first two things we have to check. First of all, we will do one thing, exercise, that is assessment of monsoon runoff we are making, and from that we have to find out uncommitted runoff. Second part is post monsoon our water level, that is very important, because say dry season water level will go down, it is natural. Whether we use water or not, water level will go down in March. Now, after rainfall, if that water level does not come up to my original level, then it is this should alert us, we should get alarmed that okay, continuously water level is falling, that means situation is not very good, means rainfall is unable to recharge our aquifer. So, if post monsoon water level is shallow, then we will make water conservation structure like pond or tank or rainwater, rooftop rainwater harvesting we can go. If water level, post monsoon water level is deeper, then we have to check whether aquifer yield is more than or equal to 2 LPS. If it is no, if the result is no, then we will go for just water conservation structure, because aquifer that does not yield will not take water also. ना, ये सिंपल ऐसे बोल सकता है, जिसका पास पैसा है वही दे सकता है, तो जो दे ही नहीं सकता मतलब वो ले भी नहीं सकता है, इसलिए जिसका यील्ड ज़्यादा है उसी को हम कंसीडर कर रहे हैं कि वहाँ पे हम इंटरवेंशन के लिए सोचेंगे. So, after that, if aquifer yield is good, we will check soil thickness, because soil is very important, because that is the first interface between our rainfall and earth. So, soil thickness, if it is not there, you will not get much water. Their scope for intervention is very less. So, say we are having highest rainfall in Cherrapunji, but in dry season in that area people suffer. They used to go to some rivers or maybe some kilometers away to collect water. Why this is happening after having so much of rainfall? More than 10,000 mm, you cannot imagine. Guwahati it is less than 2000. So, because there is soil is not there almost. If you go anytime you go to Cherrapunji, on top you will see somewhere maybe 1 feet of soil is there, somewhere it is no soil, hard rock from surface itself. So, water cannot go inside the system, it is not taking water. So, soil thickness is very important. Minimum 3 meter soil thickness you require for making any intervention, or weather thickness in case of hard rock. And then uncommitted monsoon runoff, if you are having, then only you can make intervention. So, it will directly coming to now groundwater recharge. So, when groundwater recharge, first we have to check whether any stream is nearby. If yes, go for check dam, gully plug or nalaban, those type of thing. If no, then check the slope. Slope more than 20% or less than 20%. If more than 20%, you can go for contour banding or trenching. And if it is less than 20, first you have to check clay layer at shallow level, whether that clay is there in shallow level. If clay is not there, go for percolation tank, make a pond, it will automatically get recharged. If clay is there at shallow level, then you have to check whether that layer is a thin layer or thick layer. If it is thin, say 2 meter, 3 meter only, then you can go for percolation tank with recharge shaft, RS is recharge shaft. If it is thick layer, then trench with recharge well. That Biplav Sahab has shown us some pictures that you are making filter and some tube well, like that you have to make. And even we are having many defunct bore wells. Earlier those are tube wells used to give us water, now they are not giving. Those wells can be converted to recharge well. So, this is how, following these steps, you can decide on what structure is to be made. So, protection comes is required, because today our one source may be good water it is giving, but if we do not protect it, in future it may not give us the good quality water. So, recharge structure should be fitted with properly designed filter media to avoid contamination of aquifer. And maintenance and rejuvenation of existing structures like desilting of water bodies, clearing inlet channels, encroachments, jungle clearance, strengthening of burns, repair of regulatory control assets, these are to be made. So, under Manrega many times in villages these things are done. And protecting fence. So, even in many of villages in Madhya Pradesh, Rajasthan, they are making some fence around their source, so that nobody should encroach that area, nobody should go near to that tube well. Other measures are that district authorities should ensure regular risk assessment of village. It is not a one time job. Once we have decided that it is a safe village, it may not remain safe after say 3-4 years or 5 years. So, regular some assessment is required, and wastage of water we should stop. Filling up of farm ponds, tanks, pumping of groundwater should be discouraged. Water bodies should be kept clean, and dumping of garbage in water bodies should be banned. So, if you in many times we have seen that in dug wells, what happens, now JJM is giving water to people's houses directly, tap water is there. Now, dug wells are there and people are throwing garbage in the dug well. So, they are not understanding that this garbage will contaminate the aquifer and ultimately it will reach them again, and they will get ill or sick through this by consuming this water. So, this should not happen. And well protection, it should not be, there should not be any landfill site near to it. no disposal of toxic or polluting substance, no direct infiltration of wastewater, grey water, and afforestation of area should be done, no soak pit, magic pit. Because what happens, if you see that Swachh Bharat Abhiyan, one is called Swachh Bharat Gramin. In Swachh Bharat Gramin, they are saying it as a magic pit, soak pit, this names they are giving, and all dirty water they are making some pit and throwing it, that water in it. They are not understanding this will contaminate the aquifer, then they won't be able to drink that water. And avoid sinking of additional tube well or borewell within a radius of 200 meter. When we construct two tube well very nearby, they used to influence one another and water level will go dry. So, minimum 200 meter radius it should be avoided. Apart from this, groundwater monitoring is to be done regularly. If we do not monitor, then we won't know the situation what is happening in that area. Because of that, groundwater monitoring is required, and technical support, there are many places from where you can get technical support. These are the field photos. So, that is the SOP. Thank you. So, it is a short SOP, I hope. So, if you have any question, you can ask. Okay, thank you. Madam, no. तुम्हारा है? सिगरेट चाहिए? हाँ?